We're going to look at a geometric series. Suppose that S is 1 plus R squared plus R cubed plus R to the 4th forever and ever. Okay, so we want to find out what this equals, and while we're at it, let us find out the formula for the partial sum. 1 plus R squared, let's just say up to R to the n. So to prove the formula for the bottom one, let's write S sub n. Let's write down R times S sub n. I multiply each of these terms on the right by R, and I'll get R plus R squared plus R cubed all the way up to R to the n, and then R to the n plus 1. And if I happen to subtract, well, on the left side, I have 1Sn, and I am taking away R of them. So I'm going to have 1 minus R, S sub n. And this is equal to 1. Everything else for a while canceled out, except that last term. Okay. Dividing both sides by 1 minus R, so R cannot be 1. Now, if R is 1, now we'll talk about that in a moment. S sub n is equal to 1 minus R to the n plus 1 over 1 minus R. And that's the formula for any R except 1. Now, let's just get 1 out of the way. S sub n is 1 plus R plus R squared all the way up to R to the n. And if not n, but if R is 1, if R is equal to 1, then Sn is 1 plus 1. 1 squared is 1. 1 cubed is 1. All the way up to 1 to the n. 1 raised to the n, which is 1. So we're adding up 1s, and we'll call that the first time we added 1, and that's the second time, and that's the nth time, and that's the n plus 1 time. So we're going to get n plus 1 times 1. Okay, wonderful. Now, for the series, infinite series, if R is still 1, you're going to get 1 plus 1 plus 1 plus 1 forever and ever, and that's going to diverge. Okay. Now, we just discovered that S sub n is 1 minus R to the n plus 1 over 1 minus R. Okay, well, what is going to happen if we let n go to infinity of Sn? Well, that's going to be the infinite series. And this is going to equal to the limit as n goes to infinity of 1 minus R to the n plus 1 over 1 minus R. Okay. Now we're assuming R is not 1. So what's going on here is this is a constant. In fact, as a constant, we can just bring it in front. I don't want to deal with it. As n goes to infinity of 1 minus R to the n plus 1. Now, we are going to get two answers. If R, an absolute value, so we're going to get, I claim, we are going to get does not exist if the absolute value of R is greater than 1. And the reason is this limit won't exist because you're going to have 1 minus 7, sorry, yeah, you're going to have 1 minus R to the 7. Now, if R is more than 1, R to the 7 gets bigger. And if you have 1 minus R to the 700, If r is positive, that's going to be big. In fact, if the power is really, really large, this is going to be 1 minus infinity, which is negative infinity, which ultimately gets divided by 1 minus r, and if r is bigger than 1, this will be less than 0, so it'll be positive infinity. So if r is bigger than 1, the limit doesn't exist. It's infinity. What if, now remember, if r is bigger than 1, that includes that r can be less than negative 1, like negative 2. And that's because the absolute value of negative 2 is bigger than 1. So what if r is what if r is negative? What's going on? What if r is negative 3? So you have 1 minus r to a power. Say the power is 20,001. Well, that's going to be, this part is going to be very, very negative. And 1 minus a very negative number, a very large negative number, will be a very large positive number. As this number, you add in more zeros to make sure it's odd. This is going to go to plus infinity. But on the other hand, if you raise negative 3 to a really, really, really large even number, negative 3 to an even number is going to be positive, and negative 3 raised to a really large even number will be really positive. So you have 1 minus a really large number. That's going to go to negative infinity. So it's not going to exist if r is an absolute value is bigger than 1. There is no convergence. Okay, it diverges. We can use that word. It diverges, it being this series up here. If r is absolute value is bigger than 1, it's going to diverge. It's not going to approach any given number. But now, if r in absolute value is less than 1, well, you have 1 minus r to the n plus 1. You have 1 minus, say, a third, plus or minus a third. If you keep raising it to really, really large numbers, even or odd, you'll get real small numbers. If the power is even, you'll get a positive small number. If the power is odd, you'll get a negative small number. That is, numbers close to 0. That is, this piece goes to 0, and the numerator is just 1 over 1 minus r. So this limit that we just took, the limit of s sub n, or if you prefer the limit of that, it goes to 1 minus r. And we talked earlier what happens if r is 1. The infinite series diverges. So here is your proof. I erased a lot of the proof, but it's true. This limit right here, it diverges when r in absolute value is bigger than 1. It equals 1 over 1 minus r if r in absolute value is less than 1. And it clearly diverges when r is 1. It's 1 plus 1 plus 1 plus n plus 1 plus 1 plus 1, etc. diverges. Here is your rule for the partial sum of a geometric series, and here is the rule for the infinite sum of a geometric series. If what you are raising to powers, here is r, that's what you're raising to the powers. If those numbers are bigger than 1 in absolute value, it will not converge, and if it's less than an absolute value, if r is less than 1, not only will it converge, but we can even say that it's going to converge to 1 over 1 minus r. Pretty neat. This completes this video. Subscribe if you want to see any other videos that I haven't made up yet. Please denote that in the comment section. And always, if you know a better proof or a different proof, post it in the comment section. We'll look at it. Who knows, maybe I'll make up a video showing your proof. Okay, thank you. Watch and learn.